Example 3 talks about a new kind of a distance problem. It's with wind speed and currents. And it's maybe a little bit of a difficult concept, but let's talk about it this way. If you ever looked up in the sky and you see clouds, right? They usually just sit there. But sometimes when it's very windy, you can see those clouds move across the sky. So the wind actually pushes the clouds, or it pushes leaves. It can also push airplanes. So when the wind is behind an airplane, even though we think of them as being very big, it will affect it and it will push the airplane faster than what it typically might go. Same thing when the wind is coming against a plane that's wanting, the plane's flying this way, but the wind's coming this way, they kind of counteract each other, and the wind actually slows that plane down. So these problems are going to deal with planes that are in the air flying. So we're going to talk about two things when we talk about them. I'm going to let x be equal to the actual plane speed, so like the speedometer speed in the plane. And in these situations, it's always going to be a constant. They're always going to fly like 500 miles per hour. And the wind also is going to be constant. And I'm going to let y represent how fast the wind is moving. All right, so let's read this problem. Jack flew a plane 8,400 kilometers against the wind in 7 hours. With the same wind, he made the return trip in 6 hours. So if it was going against him to begin with, when he turned around and started going the other direction, it's now going to be behind him, pushing him faster. So what was the speed of the wind? So let's read our information. Jack flew a plane 8,400 kilometers against the wind in 7 hours. So you can see I made a chart so I could be a little bit neater when I did it slowly. My kilometers per hour times the hours equals kilometers. So we got 8,400 kilometers. So that's going to go underneath kilometers in this third column right there. And it was in 7 hours. So he did that in 7 hours. With the same wind, he made the return trip in 6 hours. And since he went the same distance but just the opposite direction, it's still, he went 8,400 miles. So I put an 8,400 there. Now normally we'd put an X and a Y in these two spots, but because we're talking about these wind problems, our kilometers per hour are going to actually be made up of two parts. It's going to be made up of the plane speed, and then when it's going against the wind, it's going to slow it down, and it's going to be minus the wind speed. So the wind is going to make it go slower than what it typically would if it was in still air. And then when he's going with the wind, we still got that same speedometer speed, but this time the wind is pushing it along a little faster. So I'm going to put plus the wind speed. So x minus y, x plus y. All right, so now I'm going to do my equations using my pattern up here of multiplying first column times second column and getting the third column. So my first equation is going to be 7. And then I'm going to put my x minus y in parentheses. I'm going to multiply times the entire thing is equal to 8,400. And my second one is going to be 6 times x plus y is equal to 8,400. Now, normally I would distribute right here, and you still can distribute here and work with these two equations with your system, doing probably the addition method if you were to distribute. But I'm going to show you a nifty little trick. Instead of multiplying, what I'm going to do is I'm going to divide both sides by that 7, and that will cancel, and that's going to give me x minus y is equal to 1200, so divide 7 in and get that. And for my second equation, I'm going to divide both sides by 6, and that will give me here x plus y is equal to 1,4,0,0. All right, so now I've got a system of equations, but with simpler numbers. And if you stack those on top of each other, then you can use the addition method very easily. So here's my first one. X minus y is 1,200. X plus y is 1,400. I'm going to add them and get 2x is equal to 2,600. Then divide both sides by 2. And I will end up with that x is equal to 1,300. And once I find that x is 1,300, then I can place that in for my x in either one of these equations. So probably we'll move this over and let's just do it into the second one. So if x is 1,300, I'm going to have 1,300 plus y is 1,400. And then subtract my 1,300 from both sides. And that's going to give me that y is equal to 100. So remembering what my x and y stand for, x is equal to the plane speed. So the plane has a speed of 1,300 kilometers per hour, and the wind speed is 100 kilometers per hour. Now give a try to this next one. It's a little bit different because it's upstream and downstream, but the same concept works.